We're going to look at graphing rational functions in the calculator. So you can do this two ways. You can try to sort of find your information algebraically first and then graph it, or you can graph it first and then based off your graph sort of algebraically make sure everything you found is correct. We're just going to graph it first so I can show you how to type it correctly in the calculator, and then we have an idea of what it's kind of supposed to look like. So if we've got y equals 6 over x squared plus 1, when we graph these in the calculator, we need to make sure the numerator and the denominator are both two separate entities when we're putting it into the calculator, when we're typing it in. So when we type this in, we're going to do the numerator 6 in parentheses divided by the denominator x squared plus 1. That way it doesn't just take 6 and divide it by only the x squared. We want to divide by the entire denominator. So let's go ahead. We're going to go to our calculator, go to y equals, clear out anything that's there. So 6 divided by x squared plus 1. So this is what the graph should look like. I'm going to zoom in a little bit. Okay. So it's kind of like a bell shape, which is fine. So at least when we're trying to solve for our information algebraically, we'll at least have some idea if we're going in the right direction. So there's our graph. That's what it looks like. Let's go ahead and go back to our notes. So the X intercept, actually let's do our horizontal asymptote. So the horizontal asymptote, you're looking at M and N. So M, and I don't want X, is 0 because we have no variable there. N is 2. So when we're looking at this, 0 is less than 2. And when that's the case, your horizontal asymptote is where? Automatically at 0. And that's what our graph kind of showed too. So at y equals 0, you guys can go ahead and draw that in. It did kind of show our graph leveling off or approaching that x-axis when we put it in the calculator. So that would mean if our horizontal asymptote's at the x-axis and you guys kind of looked at the graph and you could kind of see it didn't cross the x-axis, if you try to solve for your x-intercepts, you guys would set y equal to 0. 0 equals 6 over x squared plus 1. You would cross multiply. 0 times x squared plus 1 is 0 equals 6. What happens is there's actually no x left to solve for, and you're left with a false statement. So in this case, there are no x-intercepts, which is fine. For your y-intercepts, you're going to make your x 0 and solve for your y. So we're going to solve for y with 6 over 0 squared plus 1. 0 squared plus 1 is 1. So you get 6 over 1, which is 6. So your y-intercept is 0, 6. That does match with your graph. If you go back to your calculator, vertical asymptotes. So vertical asymptotes is when we solve for our denominator. So we're going to say x squared plus 1 equals 0. Well, if you guys try to factor that, you would not be able to because it's not a difference of squares. If you added or subtracted the 1 over, you get x squared equals negative 1. When you get an imaginary value, you can't take the square root of a negative. So there actually is no vertical asymptote either. And that makes sense because when you guys looked at the graph of this function, it's continuous. There are no breaks vertically within this function. So that makes sense that there's no vertical asymptote so that you can't solve for a vertical asymptote. So if there are no vertical asymptotes, that means the domain is continuous from negative to positive infinity. And the range is going to be from that horizontal asymptote. And actually, let's find 2 more points. So if we go back to our graph, maybe you can see that there's a point at 1, 3 and negative 1, 3. But remember, don't just assume or guess. Go to your table and check. Yep, at negative 1, 3 and at positive 1, 3. We do have those 2 points, so I can plot them then on my graph. And then I'll draw it in. So the range is from that horizontal asymptote, which remember we don't actually reach, so from 0 to the highest point, which is 6. That y value is 6. It's part of the function. This is going to have a bracket with it. So you guys can graph first, then do your information, or do your information and then graph it, see if it matches, whatever kind of works for you best.